overview of my project here. So, high level, what we did was I was pretty much testing the performance of logistic regression versus regularized logistic regression. And then I did that for each of the three major um, gradient descent types: stochastic, mini batch, and full. So, we'll go through that. We're dealing with the breast cancer data set, I believe, from Wisconsin. Um, we do some feature scaling, data cleanup, and then we get to our objective function. Um, yeah, I guess everything's pretty standard as far as gradient descent comes, and then I'm just saving the values of everything, which we'll eventually test after the fact, or I guess shortly. Um, I guess there's no sense in actually explaining any of this because it's all pretty box standard. All right, so here I'm plotting the objective values versus the epic or epoch, I guess is a better way to pronounce it. And as you'd kind of expect, since gradient or full batch gradient descent, or just gradient descent as I reference it here, it's slower to converge because it has to go through every iteration. It goes through the entirety of the data set, which is why you see it kind of slowly approach. Um, Meanwhile, with mini batch or SGD, you see that it almost immediately drops down within an epoch or two, or epoch or two, to roughly zero, which is exactly what we're looking for. Again, since SGD only looks at a single value, we'd expect a pretty large variance, which is why it gets spiky, which was a little unsettling at first, but once you give it a little bit of a think, it makes sense. And similarly, you can kind of notice with a mini batch, it's a little wavy, not nearly as spiky as SGD, but particularly compared to traditional gradient descent, there is some larger variance because we're dealing with a smaller portion of the data set. So all reassuring things to see. And in terms of the regularized versus non-regularized, we kind of also see what we expect. We see the regularized above the non-regularized, which is to be expected. All right, so here's some of our performance. High 90s, which is what you'll love to see. Particularly the SGD is particularly in the mini batch are particularly performant, but not compared to the slightly more than their regularized friends. Yeah, honestly, the coolest part to me, although the graph isn't particularly interesting, I wanted to graphically show the tweaking of some of the hyperparameters. So here we see the learning rate across the x-axis, the testing accuracy across the y-axis, and then for each of the lines have a different lambda value. So yeah, I mean they all kind of follow the same general pattern, but I did that for, I believe this is gradient descent, then this is SGD, and then this is mini batch. All kind of similar, to be honest. I was kind of hoping that there would be a dramatic difference, maybe like a more parabolic shape, or a bell-shaped curve, just to kind of emphasize the importance of the learning rate, but it doesn't seem like it's all that important once you're within a reasonable range. And yeah, that's after tweaking it a little bit, I ended up spitting that stuff out. So cool project, pretty simple. Yeah.